Hello and welcome back to KHW3.1. So this was a homework that was due this week. It was assigned before the break, I believe. All right. It is said that a picture is worth 1,000 words. Mathematical symbols can be just as important when communicating about geometric diagrams. Decide which of the symbolic statements are correct based on what is given in the diagram. Justify your answers. Okay, so this is a little bit of a test of the symbols we use. So it's not necessarily math, but how do we all agree to describe math so that we can all be communicating the same? We could have used a different symbol, right? This could have been the congruency symbol. Who knows? Now there's a story for why this is the congruency symbol and why someone thought this elegantly communicated equality, and then for shapes we communicate this other little piece that means congruency. But anyway, I digress. Does the measure of angle ABC equal the measure of angle FDE? ABC, FDE, 52.9, 52.9. Yes, those do equal. Correct. Those angles are both 52.9, which means equal, which means they're equal. Okay, how about the measure of angle ABC is congruent to the measure of angle FDE? Hey, this is the same angle. We know they match. We know those angles are congruent, but that's not what this says. This says the measures of those angles. So incorrect. Congruency symbol used incorrectly to refer to numbers. So this is for things. Things are congruent. This is for numbers. So does it matter? Like, I mean, it's the same concept, right? Well, I think mathematicians continue to insist that this difference is important just because numbers just aren't like things. Numbers are different. And so because they are a different thing, they warrant a different concept of sameness. Numbers can be equal, but things can't be equal, but they can match congruently. I don't know, it's just something we go with. I mean, it's something to keep your mind on. You could insist that there's no difference and that objects can be equal and numbers can be congruent. And if you convince enough mathematicians to think that way, you might be able, people might start talking differently. But for now, everyone really believes in this. Okay. Triangle ACB. So triangle is a thing. Triangle's a thing. So this is the right symbol. If it's true, let's check if it's true. AC to B, 95, 31 to 52, 95 to FED. Yeah, yep, true. Oh, wait. Hold on. True. Wait. Angle does not prove congruent. Congruency. So, unknown. Ha, they tried to trick us. How about the two triangles are equal? No, things don't be equal. Okay, so no numbers this time, but we could still, you could still write the measure of angle CAT, whatever it is, we don't know what it is, but whatever it is, it does equal the measure of angle RUG, because the triple arc denotes that those are equal. But they did not include the M. No M. So incorrect. Using equal instead of correct. Same angle, or yeah, same angle. Correct as labeled. I hope that's how you spell labeled. Triangle cat equal congruent to triangle rug. Angle side. Yes. Yes, by AAS. No. You know, I bet we could think of a place where like congruency and equality would not make sense to interchange. Well, maybe not. I'll challenge any of you and any of the other math teachers here to find a case where it would matter the difference between congruency and equality. But whatever. For now, we'll just keep with it. So now you're making your own diagram. Obviously, different diagrams could look differently, but you need to at least include enough information to confirm that they are congruent. So I went with angle side angle, one of my favorite criteria. What about, okay, so for this one, you need an angle. A is the vertex, and then ta-da! There's the angle. It's equals 50 degrees. We label it in there, 50 degrees. I'm going to be creative here. ET, that's the is my light not on? Perpendicular. And I've said this before, but it's kind of interesting. If you have two lines cross and one of them is a 90, well, along this linear pair, this other one's also 90, because 90 plus 90 equals 180, and along the line it always has to add up to 180. But also, this one is 90 for the same reason, and also this one is 90 by two reasons: vertical angles theorem, and you could, once you have these as 90s, you could just use linear pair thinking or supplementary thinking to get that. So where two lines cross, if one of them is 90, they're all 90. And they're perpendicular. Okay, this is the most challenging one. These two angles, which share a vertex, that's the hint, add up to 180, which that means they're along a line. And here's the shared vertex at A. Oh, not only do they share a vertex, but they share a T. So that means one of their arms okay. There. Now, the measure of angle rat, let's say it's 100, and the measure of angle tack, you don't have to actually label these as long as you have it along a straight line. If it's along a straight line, it automatically is going to equal 180. Okay, my favorite part. Every time I have drawn a ray with its endpoint on a line and measured the two angles formed with the protractor, they add up to 180. So adjacent angles that form a straight line are supplementary. That is the definition of supplementary. So they're saying all the linear pairs are supplementary. But how do they know it? They've done it a bunch of times. That's knowing based on examples. You know triangle, they didn't use logic, they just used observation. Triangles that have a right angle are classified as right triangles. That is a fact. And the sides of right triangle have a relationship described by the Pythagorean theorem. That's another fact that you know. So you conclude that when you have a triangle with a right angle, if there's a right angle in it, you can use the Pythagorean theorem to find the missing sides. You had some facts, you made a logical conclusion. That is knowing based on logical reasoning. I know supplementary means the two angles add up to 180 degrees because my teacher from a few years ago just told me. Well, so you know something, maybe, because someone told you. That's knowing based on authority. It's the weakest form of knowing. But still, we rely on it, a lot, especially in school. In fact, our society kind of has a certification system for you're allowed to speak on a certain topic. Why? Well, you have a degree. You got a certificate saying that you know stuff. And it works pretty good. There can be flaws. It can get messed up sometimes. Yeah, because knowing based on authority is dangerous sometimes. We tore off the corners of a triangle and placed them together and have a straight line. Since we had everyone in our class do it, we know the angles of a triangle will add up to 180 degrees. Okay, once again, it's everybody in the class. That's a bunch of examples. Number 11. I know the Pythagorean theorem only works for right triangles because I read it in a book. It said it is a relationship to only be used with right triangles. A book is an authority. You didn't do an experiment. You didn't make a conclusion. You just read it and said, okay, yeah. There's a lot of trust based in the authority ones. Okay, and lastly, I know you can always turn a quadrilateral into two triangles because the way they look. Just draw a picture of any quadrilateral. Okay. Gonna make a really funky one. Look, it's concave. It's quadrilateral though. It's got four sides. Okay, just draw a picture of any quadrilateral and connect opposite corners and you will have two triangles. Well, I thought I was gonna cheat because you can't connect these two, but you can connect these two triangles. Ta-da! Okay, now here's the thing. I don't really need to draw a bunch of examples because this convinces me just based on the logic of the picture that no matter where I stretch these sides out to, or no matter where I push them around, you'll always be able to connect two corners and make two triangles. So based on a picture, I know the truth. Not a bunch of pictures, one diagram. That's the difference between examples and diagrams, is only one diagram necessary. And sometimes there'll be like a few cases, but still, that's not how you spell necessary. Whatever, I got to make another video this morning. Cool. Did you notice that this building's not actually built like that? This is a hill. So they changed the picture. This is all these cars are slanted downhill. The house is actually fine. Look at the trees in the background. You know what, now that I say that, I'm not totally sure. Yeah, no, look at that tree. Okay. Two diagrams of real life linear pair. I hope you were creative. I'm looking at my document camera right now, and it's at an angle. Here's the table. And the document camera looks like this. But I know this angle and this angle add up to 180. And you can also do the flagpole. There's actually also a flagpole on the wall. Alright. For two angles that have been... This is right, yeah. Oh, 90, 25 degrees. Listen, yeah. All right, we're almost done. I already did that one. AG was here. Oh no, he just moved to Texas. AJ. Oh no, wait. AJ moved to Texas. Who's AG? Oh, Agugalik. Nice. And also bye to AJ. Measure of GHK. Oh, yeah. This is the ones we have to label, right? GHK. I want to give that point a name. That means this one is 77? No, 67. That was close. I almost made a mistake. And thus concludes the key.